All right, scholars, welcome back to the middle portion of our statistical journey. We're going to start cranking up the intensity this week and solidify the concepts that we've been discussing so far. So, for today's concept, we're going to learn to describe various distributions as skewed, symmetric, or bell shaped. So, I can describe a distribution using the characteristics of its shape, center, and spread. I'll know I've got it when I can use the standard deviation to describe the variability in a distribution. It is very important that we have a solid grasp on the vocabulary that we are going to be using during our class time together. Please ensure that you are completing your vocabulary on a timely basis and making sure that you have a solid grasp of the definitions of those words. All right, for this first activity, we have a which one doesn't belong. 4 different kinds of glass are hit with a hammer, and the length of the longest cracked form is recorded. The process is repeated 150 times for each type of glass. Which one doesn't belong? Right, so take a look at the data. You should be able to zoom in accordingly. That way you can get a better gist of what you were looking at. And when you make your selection as to which one doesn't belong, please provide 2 to 3 sentences detailing why you feel that that particular image does not belong. Over the next couple of slides, you will be tasked with describing the data distributions that have been represented using dot plots as symmetric, skewed, bell-shaped, uniform, or bimodal when appropriate. In this first image, each student in the class measures the length of their step in centimeters, then walks across the room counting the number of steps to estimate the length of the classroom in centimeters. So based on the data, do you find it that it is symmetric? Symmetric means that we can reflect it over a line of symmetry and it will fall more or less on top of one another. Skewed, indicating more of our data values lie to the left or to the right of our distribution. Bell-shaped, if you are unsure of what a bell looks like, I will draw one. A bell-shaped type distribution will model a bell for as good as my drawing is. Uniform, meaning we have consistency across all data points. And bimodal, so this is one of your words that you were tasked with defining for this particular lesson. If we think back to our initial foray into statistics when we were younger, the mode of a data set is the number or data point that appears most frequently. So in the event that we have a bimodal distribution, there would be 2 data points that appear most frequently and would have a influence on the overall image of the distribution. Right, so as you can see, we have a bunch of different scenarios. So once again, please describe the distribution using the terms symmetric, skewed, bell-shaped, uniform, or bimodal where appropriate. In this case, we have 4 different dot plot distributions and then some statistical measures of central tendency, and you are tasked with determining which description coincides with its subsequent graphical representation. You can select the graphical representation so that they are enlarged and make your initial assessment. You should notice that we have similar means and medians here, so the standard deviation will determine which dot plot distribution they coincide with. The other 2 have completely different means and medians, so that should be a little bit more intuitive. And that is where we will pause.